clearly demonstrate that this is varying inversely with -1/r, which means its gravitational potential energy will become double if you make it half. I mean, if you increase the distance, its gravitational potential energy, if you make it 2 times, the gravitational potential energy becomes double. So when you increase the distance, the gravitational potential energy increases, and there is a proportion with this. Negative sign indicates that apparently the number decreases, but actually the gravitational potential energy increases, because when this number decreases, that means the value becomes less negative. So that has increased. So the maximum value of gravitational potential energy is 0, which is at infinity, practically at infinitely large distance. But as I said earlier, it could be a few thousand kilometers in some cases. Number one. Number two is sometimes they require you to calculate the gradient of this quantity. Let's say at this particular point, you are required to calculate the gradient of this curve. The question is, what is the significance of calculating the gradient? Let's say I draw a tangent to this curve, and that touches on the 2 axes in this manner. This is some position r, this is a certain value minus gm/r, and this is 0, the origin. If I take the rise over run, the gradient will be minus gm/r divided by this r, so it becomes this. When I take, let me do it in this fashion, like this. This is the gradient. I mean the rise, which is minus gm/r, divided by the run, which is r, because r minus 0. So when I simplify it, it is minus gm/r square. This is small m. So clearly the gradient of this curve at any point equals the force between the 2 masses. In this case, one mass is the planet, which may be considered Earth, and the other mass is any satellite moving about it, or any mass falling freely towards it at any position r from its center. So this is the significance of calculating gradient, and there are several questions in the exam in which you will calculate this gradient and calculate the force between 2 masses when they are at this position apart. Their centers have this distance r from each other, and the values of their masses are given. We can calculate the force between them. Another quantity, we can discuss it here as well, because there are certain similarity between gravitational potential energy and that quantity. So we should also discuss it here side by side to make our discussion complete. And that is gravitational potential. Gravitational potential is defined as the work done in moving a unit mass from infinity to a certain point in the gravitational field. It is similar to the definition of gravitational potential energy, except for one word, and that is unit mass. So if I write the definition of gravitational potential, it is the work done in moving a unit mass from infinity to a point in the gravitational field. So it is this word that makes the definition different when we compare it from gravitational potential energy. Gravitational potential energy was work in moving any mass m from infinity to a point in the gravitational field, whereas gravitational potential is defined in terms of unit mass. So many things change as a result. One thing which change is the symbol of the quantity. We denote this quantity as phi. So this is work done per unit mass. Phi is minus g m over r. Because this is defined for unit mass, so no need to write small m in the expression, which means if I want to relate gravitational potential to gravitational potential energy, I can write it U is equal to m phi. So you will remember this expression. If I multiply gravitational potential at any point, I get the gravitational potential energy at that point, and that is actually the significance of the value of this quantity, gravitational potential, because if we can map the values of gravitational potential at various points in the fields, when we keep multiplying by any mass by that value, and we get the value of gravitational potential energy at that point. So this is the significance of gravitational potential. In other words, gravitational potential is the characteristic of a gravitational field. So various values of potential are defined there, and when we want to bring in any mass at any point in that field, we can easily work out the gravitational potential energy there. What happens to this graph and what changes take place here, we can quickly understand this. Obviously, this expression will change to minus gm over r. Like gravitational potential energy, gravitational potential is also a negative quantity, so it appears on this side of the graph. It also varies in the same manner, and therefore we can say the same thing about the gravitational potential, but we said about the gravitational potential energy. Both quantities varies inversely with the r, and potential energy and potential increase as we move further away from the center of that planet. And the last thing is, what is the gradient at any point when we are plotting gravitational potential with r. So if at this point I make the tangent and take its gradient, it gives me this expression with no small mass, and this is a familiar value, a familiar expression for the gravitational field. Gravitational field. So that means gravitational field is equal to the negative gradient of negative gradient of gravitational potential. Why this negative here? Why not gravitational field is equal to gm over r square? This negative is again has a significance because if you see, gravitational field increases as we move towards the planet, whereas gravitational potential increases as we move away from the surface of the planet. So the two values increase in the opposite direction. That is why we have a negative sign here. So sometimes we express gravitational field in terms of gradient of potential, and we put negative sign here. So field is equal to negative gradient of potential. We'll have more discussion about this in the next lesson. What is the significance of this relationship? And we will try to solve a few questions here in this class. And I will share a worksheet in the next class. There is no worksheet for today's lesson. Thank you.